assessment to determine if it needs to be rehabilitated. And the results of the assessment found that the dam is in need of rehabilitation to meet the current dam safety and performance standards. However, that does not mean that the dam is unsafe. The dam is safe, it just needs to be upgraded to meet the dam safety and performance standards. So approximately 1 year ago, we started the planning process for rehabilitation of the Powdermill Dam and development of the environmental document as part of that process. And at this point in the presentation, I will turn it over to Mark Crisati if he wants to discuss the role for sponsors, and then following that, we will turn it over to Atera.
Thank you, Jim. I'm Mark Crisati, city engineer for the city of Westfield. The city's role with the Powdermill Dam and Armbrook Dam, we are the owners of the dams. We're responsible for maintenance and operation. We routinely have the dams inspected, groomed, and repaired any outstanding maintenance items. As far as the NRCS effort, the city will be responsible for participating to 35% of the construction costs. That can be in kind with right-of-way or any real estate acquisition that's necessary, and permitting along the way. I think that sums it up.
Okay, I think turn it over to me now. I'll get started. I'm going to share my screen. Again, my name is Wade Biddix. I'm retired with the U.S. Department of Agriculture, NRCS. I worked for about 34 years with the agency and was a program manager for the dam rehab program in Virginia. And so I'm very familiar with the planning process and been involved in water resource activities for many years, as well as a lot of the team that's put together. Tonight, I'm going to be doing a lot of the presenting, you'll see here with Tim Sweeney, Peter Massapus, Brian Toombs, and Carl Gustafson. But there are other team members that are not present tonight that have also been part of this planning effort. So I'm going to walk through this PowerPoint, or the team will, and we will have plenty of time at the end for questions and answers. Hopefully any input that might be coming from the public. So I have plenty of time for that a little bit later. So I'm going to go ahead and get started, and we'll run through this PowerPoint. It is quite lengthy because we go into a lot of different details here tonight. So it will hopefully flow fairly well. So today's objectives, we'll summarize the dam rehab program, talk specifically about planning activities that have gone on since last fall, and you can see the different types of things there, as well as discuss the planning schedule and encourage input and contributions by others during the Q&A. Some key players in this planning process. The City of Westfield is the lead sponsor. The Hampton, Hampshire Conservation District is also a sponsor of these dams in the Powdermill Brook watershed. The technical support is provided by USDA NRCS, and then there's various technical contractors associated with the project. The NRCS has assisted since 1948, and you can see the map there, with almost 12,000 dams across the country. So Congress back in 2000 decided that this is part of the infrastructure, just like roads and bridges and other infrastructure out there that needs to be upgraded. So they passed the dam rehabilitation amendments to the small watershed program. So that's how all this got started. The only dams that are eligible for rehab under this program are those that originally built with NRCS or NRCS assistance. Rehabilitation is defined by you can protect the integrity of the dam, extend the service life, and prolong beyond the original life, replace any deteriorating components, repair them after catastrophic events, or upgrade them to meet dam safety laws, or decommission. And as Jim said, this dam is not in imminent threat of failure, but we're upgrading it to prevent any catastrophic issues down the road. The rehabilitation planning and implementation process here is an application, site assessment, and risk analysis, ranking of those applications, and then the project planning. So we're well into the overall process, and ultimately design and construction will come later. The cost share with the program with the local sponsors, Mark mentioned this a little bit, but NRCS can pay 100% of the planning cost, 100% of the design cost, and 65% of the total project cost, not to exceed 100% of the construction. And any NRCS staff costs are paid 100% by the agency. And then the local sponsors pay 35% of the total project cost, and they are responsible for any permit costs, 100% of those. The purpose and need for action with this dam rehab project, we want to provide the originally planned level of flood protection to the watershed for the next 50 to 100 years while minimizing environmental, economic, and social impacts. So we're looking long-term here. It's not just a real quick fix. The need is that the present dam structure does not meet current safety and performance standards. So action is necessary to reduce the risk of flood damage to homes, commercial facilities, roads, bridges, infrastructure, as well as to reduce the risk of loss of life due to the breach of the dam. So that's the basic reasons for the project. Some specific statistics on the dam. It's known locally as Powdermill Dam. It's on Powdermill Brook. It was built in 1965 as a single-purpose dry flood control dam. The drainage area is almost 3,000 acres. At high water, holds back about 68 acres of water. It's 642 feet long, 50 feet high. It has a 48-inch pipe going through the dam. It was originally constructed as a high hazard dam. So just to make sure everybody's familiar with what we're talking about here, we have basically an embankment across a valley, and then you have a riser out there that controls the normal and reservoir impoundment. You have a pipe going through the dam that outlets down here. Normally you have a berm on the back slope, and then you have an emergency or an auxiliary spillway that prevents the dam from overtopping. If you look at that a little bit from the side angle, we have an embankment. Over on the left, you have their normal pool or the sediment storage that's behind the structure. Then you have all this blue area here is the flood storage. That's the normal flood storage during a storm event. You have an auxiliary spillway that outlets around the dam. Then you have the pipe through there. So this is what we're talking about when we're talking about a typical flood water retarding structure, and Powdermill Brook is very typical with that. The hazard classes of dams, you start in the lower left, you get the Class A, which is a low hazard dam. Basically protects agricultural land or very rural land. And then you step up to Class B, or a significant hazard dam, when a breach of the dam would cause significant infrastructure damage and loss of dollars and value. But up here at Class C, you have a breach of the dam would cause potential loss of life. So this dam is without question a Class C or a high hazard dam. And the State Bureau of Dam Safety, they also agree with that determination. I want to show you a few pictures of the dam, the project area. This is a picture of the riser, the top of the riser, and you can see the water in behind the riser. And there's quite a bit of Phragmites around in the area. This is a little shot of the same area. This is the riser down here on the right and the embankment. And this is where all the floodwater would store up back in here on the back slope. This is just the entrance area. The flood pool areas to the left and the outlet is to the right. This is the back slope of the dam. You can see the bench there, the berm. That's just to help stabilize the structure. This is the outlet of the pipe through the dam. This is the 48-inch pipe that hooks on with the riser at the upper end that controls the normal pool level of the reservoir. So the condition or status of the dam, like we said, it's not in imminent danger of failure, so don't panic. Don't say the sky's falling. We're not in that situation. We're taking preventative measures to prevent problems later. The dam was inspected annually and regularly mowed and maintained. And we've talked about the assessment that was done back in 2010. It was given an overall condition as fair. There was some significant erosion caused by some off-road ATV kind of vehicles on the embankment and the slopes and the auxiliary spillway. And they requested assistance back in 2015, and the contract was awarded for planning, developing a plan in September of last year. So the key issues here, I think, are that the dam does not meet current NRCS and Massachusetts Department of Conservation and Recreation dam safety and performance standards. Some of the deficiencies include the dam currently overtops since the auxiliary spillway does not have the capacity to pass the design storm, and that's NRCS criteria. The auxiliary spillway is susceptible to erosion, resulting in breaching of the spillway during the design storm. The embankment drains need to be replaced. The principal spillway pipe requires a filter diaphragm, and there's inadequate sediment storage for another 50 years. So back in last year, November of last year, we had some local public scoping meetings. And scoping, it's basically to try to set some sideboards for what you're going to do, what you're going to study, and limit the range of actions, alternatives, and impacts considered. So scoping is used to identify the significant issues to be analyzed in detail and to eliminate from detailed study issues that are not significant. So we had that meeting couple of meetings last November. So the groups of resource concerns are broken into soils, water, air, plants, animals, humans, and ecosystem services. So we're going to talk a lot about those in a little bit. The key here is we want to focus on, is it relevant, yes or no, to the proposed action? And we're talking about rehabbing a specific dam. So that's how we group these different resource concerns. So now I'm going to kick it over to Tim Sweeney. And Tim, if you can go to the top of your screen, your scroll down, and just there's a remote control. If you can take remote control there, click on that. On your drop down, you should get control of the screen. You see that on the right top when your toolbar comes down? You're muted, Tim. You're muted.
Yeah.
There.
No, what I'm seeing, Wade, is I've got zoom ratio, hide video panel, request remote control.
Request remote control.
Okay.
All right, now you should have control of the PowerPoint. So introduce yourself and take off.
My name's Tim Sweeney, and I've been doing watershed planning for 20-some years with the Natural Resource Conservation Service, so I have fairly good background in watershed planning. I've worked at the Water Management Center. And what I'm going to talk about today is this new facet of watershed planning that the agency requires us to deal with, and it's called ecosystem services. This is a new dimension that we have to look at based on NRCS policy. The simple definition of ecosystem services would be the social benefits that are derived from the environment, be it a wetland, be it a woodland, be it just something you look at on a landscape. What are the social benefits of having that resource present? And like Wade said earlier, we're only concerning ourselves with those ecosystem services that we feel are significant in decision-making for this project. I got carried away there. Wait, I'll have to go down here.
And while you're doing that, I'm going to interrupt for just 1 second. For those of those who are on here and watching, there is a chat bar that you can pose your questions. If you'd like to use that, please use it. Peter Cowles just posted it up. I don't know if everyone caught it. So if the public has any questions or any other officials that are here have questions, please use the chat bar. Thank you. Go ahead, Tim. I'm sorry.
No problem, Al. Okay. There are 5 ecosystem services that we typically look at, but we felt that we might have an impact on 3 different dimensions of ecosystem services, and they would be the regulating service, supporting service, and cultural service. And I'll go on and kind of look a little deeper at those 3 areas of concern. Under regulating services, one of the categories is flood and disease control. And of course, we're going to work on a dam, so we're controlling or mitigating flooding. And because we're going to mitigate flooding, we also will have an impact on disease transmission through the water body. And that, in terms of the supporting ecosystem services, there are two categories underneath this one dimension, and that's nutrient cycling and soil formation. And because we're going to disturb some soil, and when we disturb soil, we're going to have an impact on the soil microbes and the way soil is formed. So we thought it would be important to look at nutrient cycling as it relates to this project. The same holds true for soil formation. Because we're going to be disturbing the soil, even though in most cases these soils that we're working with have been previously disturbed by the existing dam, there may be some new areas that we will disturb during the construction process. And then the last concern that we have has to do with the cultural ecosystem services and the recreational use of the area, the walking path over the top of the dam and the trails associated with the dam site itself and the park. We felt were significant to the public, so we're evaluating the effects on those recreational resources. There's also an aspect of an aesthetic view shed, which is, it's just nice to sit in that gazebo down there and just maybe sit there and look out at the landscape and just watch the birds and so forth. And we refer to that as an aesthetic value and what you can see from any given point. So in our particular case, we have a couple residences that are close by that have a specific view of the park area and the dam, and we were concerned about the impacts to their view shed. So that brings us to the existing conditions discussion. And I think, Wade, are you going to continue on with that existing conditions?
Yes, here we go. All right, the existing conditions for the dam. Right now, we have prime farmland soils and soils with statewide importance, which are required for us to take a look at. We have a little over 4 acres of prime farmland, 8.6 acres of farmland, soils of statewide importance. Water quality, the reservoir and the brook are listed as impaired water bodies. The brook is for algae, E. coli, turbidity, and sedimentation siltation. The reservoir for E. coli. And there's no wild, scenic, or recreational rivers in or near the project, so that's good. Wetlands present, you can see the acres there. They're fairly small of the different types of wetlands. Vernal pools, there's one certified vernal pool that's several yards northwest of the dam, but there are no vernal pools real close to the dam. Plants, no federally listed or state listed threatened endangered plants in the project area. I mentioned earlier there is some Phragmites present in the freshwater wetlands in the pool above the dam. Animals, we have one federally listed threatened endangered species, the northern long-eared bat. There are several state listed species that are potentially present. No fish or wildlife identified, no unusual fish or wildlife, no known invasive fish or wildlife species. There are no known occurrences of bald or golden eagles nesting within 1 mile. But there has not been an official survey conducted over the entire project area. The social and cultural resources, the dam and surrounding area is maintained by the city of Westfield. It's not a federally or state designated park or natural area, and it is valued for the scenic beauty by 2 adjacent homes and for outdoor activities by local residents. There's no historic properties within 1 mile of the dam. The recreation side, there is no designated recreational area, and the land surrounding the dam is occasionally used for passive recreation activities such as walking or fishing. All right, environmental justice and civil rights. The area population has some diversity, 77% white, and you can see the breakdown of the other races, 84% non-Hispanic and 16% Hispanic. The area within the breach downstream of the dam compared to the city of Westfield, Hampton County, and the state of Massachusetts has lower per capita income, lower level of poverty, higher median household income, and a presence of a minority population. There are also 4 Indian tribes that have expressed interest in Hampton County that we'll keep apprised of the project. Some economic impacts of the dam. The watershed was modeled with the dam in place and with the dam removed. So here's what we found. The flooding impacts to downstream properties, there's about 118 residential houses that would be impacted, 29 apartment complexes, 30 commercial buildings, 3 public buildings, a total of 180 structures. If you look at the economic impacts or the damages from those and compare the without dam on the left and with the dam on the right, you can see the damages go down significantly if you take, with the dam in place. So the benefits of the dam are associated with all the different buildings, 26 different roadways, public and private, 3 different stream crossings, for a total of about 194,100 average annual benefits. That's what we're seeing, the with dam and without the dam. Those are significant benefits of the dam being in place. And now I'm going to turn it over to Peter Massapust, and he's going to talk about the different modeling and the results of that. Okay,
All right.
Well,
So you should have control now, right? So we performed several analyses to support the rehabilitation design of the dam. In addition to those that Wade already mentioned to support the economic analysis. So one of the first steps was to evaluate future build out in the watershed to make sure that when we rehab the dam, that is designed for future build out conditions that take into consideration zoning requirements and future potential build out. So we obtained data from the city of Westfield and used a fairly complicated GIS algorithm to figure out what the build out conditions would look like in the future. So that's one of the first steps in our analysis. We also obtained most recent soil data from USGS. And based on that, we reanalyzed the runoff curve numbers, which essentially mean how much of the rainfall that falls onto the watershed is then transformed into runoff and flows towards the dam. Our analysis also included time of concentration reevaluation. We visited the site after we did the initial analysis in GIS. We ground truth the various segments of flow from the headwaters, the watershed, and came up with an updated time of concentration that reflected essentially the longest flow path in the watershed. And all this data was then used to create new hydrologic and hydraulic model. The software that's used for these projects called SITES, developed by NRCS, and the results of the analysis showed that, or confirmed, the previously performed analyses during the dam assessment, that the dam is overtopped, and it would have to be raised to elevation 205 if the spillway capacity is not increased. The design top of dam elevation, or the as-built top of dam elevation, is approximately 201.3 feet. So that would require a raise of 3.7 feet. However, along the existing crest of the dam, there are several depressions. Portions of the crest are a little bit higher. So it'd be very simplistic to say that the dam has to be raised by 3.7 feet, but overall it needs to be raised to elevation 205. The other outcome of the analysis showed that it breaches during the design event, and it also showed that it's not overtopped during the design event from DCR dam safety standards, but the spillway is also breached during that event. I guess the difference is that DCR for existing dams uses a smaller design event than NRCS. It's only half a PMF, and that is the reason why the dam is not overtopped during that design event. We also had to evaluate sedimentation in the reservoir over the year, project future sedimentation. So sedimentation is accounted for in the routings of the storms. And this was a little bbit challenging because the dam was originally designed as a dry dam, meaning that there should not have been a reservoir behind the dam. However, at some point, after the construction, that pond drain was closed. Water started to accumulate, and as a result of that, more sedimentation occurred. There are also some other sources of sediment that probably were not anticipated during the design, such as the landfill. There was some logging upstream of the dam. So, you know, our sediment survey looked at all those areas behind the top of the dam, behind the dam, and we came up with a you know, annual rate of sedimentation, and we also estimated how much sediment capacity there is left. So the outcome is that there's not enough sediment capacity left for the additional 50 years or whatever the additional design life will be, and therefore any future rehab options will have to account for additional sediment that's carried into the reservoir. And I think that's about it. So I'll hand it over to Brian.
So I am Brian Toombs, again with Schnabel Engineering. I'm going to talk about the geotechnical and structural aspects of the dam. I'm having trouble advancing the slide, Wade. Let's see. Oh, there we go. Okay. Yeah. So first I'm going to talk about the geotechnical investigation. So geotechnical is really just a fancy word for soil or subsurface. And part of the evaluation and study of the dam involves actually investigating what is below the surface. You know, what is the dam actually made of? Comparing that against kind of historical record, the design documentation, and then also evaluating the performance or the anticipated performance of the dam through a number of loading conditions to make sure we expect it will perform as originally designed and as needed. So our investigation had two focus areas: the embankment. We drilled a number of borings through the dam embankment, as well as the auxiliary spillway over on the left abutment. One of the key items we were interested in evaluating and kind of quantifying or classifying was the original stream channel, as this kind of lays below the dam and is an area where the subsurface condition might be a bit different. We were successful in doing that. Our program included a total of 9 borings and 4 test pits. The borings, you can see the photo of the drill rig there. These are deep, and they allow us to kind of penetrate the dam while causing minimal disturbance to the structure. We can run a series of kind of in situ tests or downhole tests to gather data on the dam, as well as retrieve samples of soil for further testing. And then the test pits were done in the auxiliary spillway, and that allows us, that's using an excavator. It allows us to put, you know, actual eyes on what lies below the ground surface, as well as collect samples. In addition, we installed 4 piezometers, or essentially groundwater or seepage monitoring wells, to allow for a bit more of specific data collection and understanding of seepage through the dam and through the foundation soils below it. We also ran some in situ testing. It's called slug testing, but it basically is facilitates changes in water levels in the wells, and then we can measure how quickly the water moves in and out of the soils. So I think what I'm trying to say is we ran a fairly comprehensive and detailed investigation to really get a good handle on how the dam is constructed and what the natural setting is. And then, like I said, we ran some in situ, which is in place testing in the holes and test pits, as well as we collected samples for laboratory testing of soils. You can see the photo on the bottom of the slide there. And it's kind of an interesting layering. So just an interesting point about this dam is that it is located on the western side. It's actually the Powdermill Brook is a tributary to what ages ago was the glacial lake Hitchcock. that was in the Connecticut River Valley, extending from Connecticut all the way up into Vermont. And as a result, this area has fairly unique geology in terms of the soil deposition. And actually, without going into too much detail, you can see in the photo kind of the interbedded layers, which were basically seasonal deposits. So that's something that's a bit unique to this area, and we really wanted to make sure we understood it well. There we go. So once we'd gone to the field, we collected all that data. We ran a series of analysis and evaluations to kind of evaluate the dam structure and consider its potential performance under everyday conditions as well as extreme conditions. The first such analysis has to do with filter compatibility and the internal drains. Essentially, this is trying to make sure that as seepage flows through the embankment, that there aren't any issues with that water carrying particles. So we have to run what's called filter compatibility to make sure that the soils downstream of upstream soils are sufficiently filtered, so only water can get through, and that the finer soils don't move out of the dam, which can be problematic. So our analysis showed that we looked at a lot of different interfaces in the dam, and everything appears to be acceptable. It's great news. However, there's an existing tow drain. It's hard to see. It's this kind of purple thing on the downstream side of the dam here that is intended. It's basically a sand trench with a pipe in it that's intended to collect seepage. That is what is called corrugated metal pipe. That was the industry standard when this dam was constructed, but is no longer an accepted practice. These pipes are corrugated metal. They're subject to corrosion and erosion and collapse, which can lead to soils and the dam basically being washed out through the pipe, which can be very problematic, especially at the age of this dam, which is about 55 years. So that's something that we noted. And then there's also no filter diaphragm on the spillway conduit. If you look at that kind of gray image up there, NRCS design requirements require that there's basically a zone of sand that fully surrounds any penetration through the dam. Unfortunately, the Powdermill Dam does not have that. So we noted that, and that's a recommended repair. In terms of, we also looked at a couple of performance evaluations, such as seepage, stability of the slopes, and basically there was no seepage deficiencies identified, and the slopes are relatively gentle. They're all 3-to-1 or flatter, and they meet criteria. We also evaluated what could potentially happen to the embankment under a significant earthquake event. And we found that the dam is anticipated to meet criteria. There it goes. The other piece of the dam that we evaluated is the principal spillway riser. So Wade showed a slide of this before. It's a slightly different angle on the picture. But it's basically a twofold kind of assessment. First, there's a visual and a video inspection of this concrete structure and the conduit that passes through the dam. There's actually divers climbed up the 48-inch conduit. There's a plug installed on the upstream end so they could get access, when no water was flowing. And the results were that the concrete structure was found to be acceptable. And the conduit as well is in reasonably good condition, although there are some joints that require some grout repairs. You can kind of see in the photo, there's a little inlet gate at the front. That gate is inoperable. It's in the closed condition, and that will need to be replaced or removed. Discuss that a little bit later. So that's kind of the field component of our evaluation. From an engineering standpoint, we ran a series of calculations to evaluate the riser in terms of stability. We look at overturning, which is basically if it tips over, or sliding under seismic as well as extreme loading conditions. And our analysis showed that the riser is stable and expected to perform acceptably during design loading. So the takeaways from this again are to probably replace or remove the pond drain gate that is non-functional. And then you either remove the sediment from around the pond drain gate or that low-level inlet on the upstream side that has accumulated over the years. It may prevent some flow. And then also there's a bunch of debris kind of captured on that. So these are pretty, mostly maintenance type clean outs, but there are some trees and woody debris caught on the weir that need to be removed. So I think with that, I will turn it back over to Wade.
Okay, thank you. And I think we're having a little bit of trouble with the guys advancing the slides because I was advancing those for you, Brian. So I'm going to stop share just for 1 minute and then come back and share it again, and hopefully that'll clear it up. So hopefully that will clear up the problems for later. All right, we're down to, now that we have the basic existing conditions of the dam, we started looking at formulating and evaluating alternatives. So what we do with the formulation process, it begins with identifying various alternatives that will meet the purpose and need statement goals. And this statement requires that alternatives meet current safety and performance standards and provide at least the same level of flood protection that was provided originally by the dam. So those are our guidelines. But what I'm going to show you right now are just some typical structural and non-structural alternatives for rehabilitation of dams. Some of the required alternatives that to be considered are the no federal action, decommissioning, removal, non-structural, which we elevate, relocate, or we zone downstream of these dams, and then you can have structural rehab to the current criteria. So here is a articulated concrete blocks which armored a spillway in called Nichols Dam in Westboro, Massachusetts. If you look very closely to this area, you can see these articulated blocks are basically cabled together into mattresses, and then it helps armor it. It's better protected than a vegetative spillway. Here is a labyrinth weir down in Georgia that you can see this. You have the impoundment up here, the embankment. There was a path in front of it, and this one is in a dry condition. This is a labyrinth weir. It's basically just a different cycle. You can see one of these is called a cycle. Here's one in Virginia, and you can see this is a little different design where the impoundment comes right up to the base of the labyrinth weir and the cycles. So this is a way of armoring the auxiliary spillway rather than a vegetative spillway. This is a roller compacted concrete spillway down in Georgia on a dam in Georgia. They've really armored the entire dam and the abutment areas. You can see these are steps down with the roller compacted concrete. It's not reinforced concrete, but it's a roller compacted concrete. Here's another roller compacted concrete shot of a spillway in Virginia that is very similar to that one in Georgia, except this is just the auxiliary spillway is armored, not the entire embankment. Other alternatives, non-structural alternatives is to go downstream of the dam, and rather than upgrade the dam, you may acquire any properties that are being impacted by flooding and are at risk if the dam should fail. So in this case, house acquisitions, you might have, total removal of the house and site restoration of that property. In some cases, elevation of those affected properties. This one is elevation is underway, and you can see it as a finished product. So you remove the damaged property and get it above the flood elevation. Some other non-structural options that we consider are flood warning systems. Those might be where you have a dam farther upstream, that you have a significant lag time, maybe more than an hour to get people out of the floodplain, where you have dams in fairly close proximity to the affected downstream properties. Flood warning systems do not work. You just simply don't have enough time to get people out of the floodplain. Flood proofing, also you can do small ring levees or dikes around individual homes or properties. So that's an option in some situations. So now I want to show you a couple of slides of this is a typical dam, and this is an auxiliary spillway here. You can see that water is flowing in that. It's smooth. It's exiting around the dam in a flood situation. This was over in Pennsylvania. But at the end of that, when you turn that water loose, it starts causing a lot of damage and starts chewing back into the dam and into the auxiliary spillway, and ultimately can eat through back into the pool. Here's another one in Massachusetts, the Granville Dam, that breached in 2011. It's very similar to what we just saw. It just continually eats back, depending on the flow and what the auxiliary spillway is made of. It can ultimately breach the entire structure.
Wade, can you leave that one back up for a second?
Yes.
So just so everyone is aware in the public audience, that is our drinking water reservoir in Granville, Mass. And that is what happened as a result of hurricane/tropical storm Irene.
Very good. So it can happen, and I think there are a lot of cases as we see more severe storms. You can certainly have this happen in a situation. So we're trying to, in a rehab program, is to try to prevent these types of situations. So when we do any kind of formulation of alternatives, we always look at a no action. And a no action means no federal action, meaning what would the local dam owners and sponsors do in the case if there were no federal funds involved. So the city has chosen in this case to select the least cost alternative that meets NRCS criteria and the Massachusetts Dam Safety criteria, safety and performance standards. So we'll go into a little more detail on that in a minute. So some of the alternatives that we considered but eliminated from detailed study is decommissioning the dam. We saw earlier the benefits of the dam. So this alternative would remove the dam, the flood storage functions, and reconnect, restore, and stabilize the stream. Downstream flooding conditions would be similar to those that existed prior to construction of the dam. And any properties within the 100-year floodplain would need to be protected. So this includes addressing induced damages to downstream properties, roadways, and crossings. So we did enough to say this is going to be very expensive. And just in an order of magnitude, we said somewhere between 15 and 20 million if you did that. So that's a pretty exorbitant cost. So we eliminated that from detailed study. The non-structural, that alternative would leave the dam in its current condition while relocating or flood-proofing downstream properties. And it would involve elevating, flood-proofing, or relocating buildings, elevating, modifying roadways, stream crossings, purchasing deed restrictions to restrict any future development. And that was even more expensive than decommissioning. So we looked at those, but the more we got into it, we realized these were not viable alternatives for this dam. So now, Carl, I'll turn it over to you. Carl Gustafson's going to go into the conceptual design of the alternatives that we considered.
Thank you, Wade. I believe I have control now.
Okay.
So again, welcome everyone. My name's Carl Gustafson. I'm an engineer with Atera. I've worked for Atera since about mid-2017. Prior to that, I worked with NRCS for about a little over 40 years as an engineer, retiring in December 2011. And some of those years, I was a state conservation engineer here in Amherst, Massachusetts. So I'm well familiar with Powdermill Dam. So Wade, I was trying to get the next slide. So as Wade mentioned, the alternatives, the 4 alternatives we developed in detail as the most cost effective and environmentally sound to proceed on to upgrade the dam to current standards, as well as maintain the downstream flood protection. That's where I'm going to give you an overview of each of those. One alternative is to upgrade the dam to the Massachusetts Dam Safety Standards without any federal technical or financial assistance. There are 2 alternatives using a labyrinth weir to improve the auxiliary spillway hydraulics. And there's one alternative completely using a roller compacted concrete in the auxiliary spillway. So the difference between the no action or no federal assistance and the other alternatives, as Peter has mentioned, is the passing of the probable maximum flood. So the state criteria allows you to at least pass 1/2 of the probable maximum flood. NRCS criteria wants to pass the full probable maximum flood without overtopping the dam. The other requirements are about the same and how they affect the dam. So just to give you an area view of the dam, it's located, you get access from the end of Edgewood Drive, Edgewood Street, where the road ends and the power line right-of-way starts. You come along the power line right-of-way, you can see the power lines here, the top of the dam. And then on the bottom, on the north side of the dam, is that concrete inlet Brian showed you pictures of. Powdermill Brook comes in. The 48-inch diameter concrete pipe goes underneath the dam, outlets down here. And the tow drain, the corrugated metal tow drain, is about in this location. Top of dam, the auxiliary spillway here, it's about 7 feet lower than the top of dam, and that's where the flood flows would bypass on that side.
Carl, let me interrupt you.
Yeah.
We're not seeing your pointer. Apparently, the sharing of the PowerPoint is not working properly. So I can advance when you need to, but we're not seeing your pointer.
Oh, okay. Okay. So go ahead and advance, please. So all the alternatives, the no federal action alternative, as well as the 3 alternatives to bring it up to NRCS standards, all involve the same amount of work on the embankment themselves. Basically, the difference for this side boils down to treating the auxiliary spillway. So the principal spillway pipe joints would be cleaned and regrouted, and all the concrete riser and the concrete pipe would be cleaned and a sealant applied to extend the life another 50 years. A sand gravel blanket, that filter diaphragm, would be constructed around the 48-inch diameter pipe near the downstream end, as Brian said, to prevent any erosion of fine materials from seepage through the dam. The existing corrugated metal pipe tow drain would be filled with grout, which is essentially a concrete slurry. Rather than remove it, it would be a deep excavation, and a new tow drain would be installed closer to the downstream tow. And there's a small amount of sediment that would be removed adjacent to the principal spillway inlet, and the pond drain gate would be removed. There is some minor stabilization work on the downstream abutment, wet areas, some erosion, as well as some trees encroaching on the right downstream abutment that would be taken off, removed also. And all the alternatives result that there is no change in the current levels of flood protection downstream as a result of the project activity. The next slide, please, Wade. So just to quickly go back through the slides, the articulated concrete blocks, Powdermill, the bottom of the spillway there is about 260 feet wide, which is a lot wider than this photo, but there gives you an idea what the no federal action alternative would be using articulated concrete blocks that goes up on the side on each berm. Next slide, please. Here again, the Labyrinth Weir. This one has floodwaters. The next slide, Wade, again. So this is what Powdermill would look like, because the normal pool levels, it's essentially a dry dam. So you would see the concrete surface as you do here. Next slide, please. And again, the reinforced or the roller compacted concrete alternative would look similar to this, except the sidewalls would be reinforced concrete. So again, the no action alternative involves bringing the dam up to DCR standards by stabilizing the existing 260-foot wide spillway using articulated concrete blocks. Slide, please. So it's unfortunate I can't get the cursor going here, but if you start on the right side where the power lines are, that's where you'd enter in, and then there's the top of dam that goes across. So all the work on the dam is the same. You have the pond drain inlet at the bottom of the page. The dotted line represents the 48-inch diameter conduit. And you see the joints would be grouted, all the concrete would be sealed. That's the new drain that would be put in. The old drain would be grouted, sealed. And there's two little areas on that right abutment where there's some work stabilizing the eroding area and clearing some trees. So that happens all four alternatives. So the no action alternative with the ACBs, you see that on the left side, how that would fit into the existing spillway, tightens right up against the railroad right away, and then would flow down. The next slide shows a profile. So the ACBs pretty much follow, it's excavated out and they're placed in on that gravel bed. They pretty much follow the existing ground surface there on the existing spillway. Now, alternative number one, to pass the full probable maximum flood, we'd utilize the Labyrinth Weir, the 6th cycle at the photos. It's about 158 feet wide, and it has the roller compacted concrete outlet channels. So next slide, please. So again, everything on the embankment stays the same. The riser work, the conduit work, the toe drains, all that is the same. And you can see how the 158-foot Labyrinth Weir fits inside the existing spillway. And just to the left of that, we have to fill in the rest of the auxiliary spillway with a berm to prevent the water from going around that. So the next slide. Notice the ground line, the crest of the auxiliary spillway stays the same. So the flood retention level at that elevation stays the same at the top, actually a little above that way. The top of the Labyrinth, yeah, there you are. That stays the same in all alternatives. And you see we have the weir, and then it steps down using the roller compacted concrete. That's how this would fit in. Next slide. By raising the dam a couple feet, we gain some head on the Labyrinth Weir. We can reduce the width of the Labyrinth Weir to about 106 feet. Next slide, please, Wade. So again, everything on the dam stays the same, the riser, the pipe, the drains, but the Labyrinth Weir now is only 106 feet wide, and the roller compacted concrete, the berm that Wade's pointing out there, is a little longer. Again, it ties in to prevent water from going around. And then the roller compacted concrete chute. Now, if you could go back. So you're thinking of costs. When you look at this, there's a lot less concrete involved in this alternative. Earthwork is a little more earthwork. We're raising the dam. You can see the hatched area, how the dam would be raised. But you might be thinking that this would cost a little less because there's a lot less concrete. Next slide, please, or actually two slides. one more. So the third alternative raises the dam by 2 feet and makes the auxiliary spillway a little wider, 265 feet wide, excuse me, and utilizes roller compacted concrete for the entire structure. So the next slide, please. So you can see the dam work, the dam is raised, the hatch area, everything on the dam is the same. And now we have a lot wider auxiliary spillway. It's tied a little tighter into the railroad right away. And then it exits on the downstream side, a little bit of a berm there. And the next slide. So there's no weir that we've seen, the labyrinth weir. You saw the weir at the ground level, the crest. Roller compacted concrete would start at that same level, and then it steps down to the exit channel. Next slide. So that's an overview of the 4 alternatives. I'll turn it back to you, Wade.
Okay. The comparison of alternatives, we're going to first look at cost, and then we'll look at the environmental and other factors associated with each of these alternatives. So we looked at this is the estimated construction cost right now of the no action would be $4,555,000. The first labyrinth weir, the little wider, is almost 7.3 million. The labyrinth weir that's 106 feet wide is a little over 6 million. And then the roller compacted armor alternative 3 is almost 8.5 million. So there's your estimated construction costs. When you also include design cost, engineering, quality control, contract administrative, all those kinds of costs in here, we're looking the no action being no federal action at all. It would be 100%. The city's share would be 6.2 million. The labyrinth weir, the wider one, is about almost 9 million, and the other one 7.7 million, and then the alternative 3 almost 10 million. So those are your project costs estimated at this point. So,
Excuse me, Wade,
yes.
just for a comment on that, just for clarification, the 3 federal assisted ones, that would be reduced to a 35% cost share, correct? For the city?
That's correct. That's correct. This is
So
this
they
is
would
the
actually come
total.
out cheaper.
Yes,
city.
and I'll show you those estimated costs in just a moment.
Thank you.
So right now, what we were saying would be the preferred alternative based on the NRCS agency planning policy from principles, requirements, and guidelines. They state that the federal investments in water resources as a whole should strive to maximize public benefits with appropriate consideration of cost. Public benefits encompass environmental, economic, and social goals, include monetary and non-monetary effects, and allow for consideration of both quantified and unquantified measures. So what this is saying is, if there's some overriding issues out there that maybe we can't quantify or we can't put a dollar value on, then we can consider that, but we should consider cost as a viable thing to look at here when we're looking at these preferred alternatives. Alternative 2 right now is the one that is the narrower labyrinth weir. That's the one that we're saying is the preferred alternative that maximizes public benefits with consideration of cost. So that's the raise of the dam 2 feet, construct that 106 foot wide labyrinth weir along with roller compacted concrete spillway at a total cost of about 7.7 million. When you break that down to federal costs of almost 5.6 million and non-federal costs of about 2.1 million. And again, these are planning numbers. This can certainly change, and once you get into final design, because there may be some tweaking of these numbers. And certainly you know, this is an estimate at this point. All right, I'm going to go on to a little more detail, assuming that that's the preferred alternative that comes out of this planning effort. Here's a potential, and again, these are planning slides, and a lot of these are still things in the works. But right now, if you look at, this is Edgewood Street coming in. The area that's marked here is a construction limits of disturbance. This would be the area that potentially would be ingress and egress, staging of materials and supplies, things like that. And then the dam for work all in the, along, you heard Carl talk about all the different components of the project involving the dam as well as the auxiliary spillway and all over here to the railroad. All of these areas would be potentially disturbed during the construction activity. So what we've done is took a look at, if this were to be the limits of where we would have soil disturbance, what would be the environmental and social and economic impacts of that? So I'm going to go a little bit into that. And again, these are planning figures and maps at this point. So keep in mind that we're looking at the existing condition. We already have a dam. We're trying to modify the original footprint of that dam and looking at the impacts associated with these different components. So in environmental effects, we are likely to experience some temporary disturbance of compaction, during construction. That's typical. Wetlands, surprising here, we might have some small acres of loss associated with the downstream toe of the auxiliary spillway. There would be a net increase in some freshwater wetlands in some areas along the downstream aprons. Taking the existing impoundment and converting it back to a dry pond would eliminate some of those potential wetlands upstream, but they're likely to reestablish once it's back in dry state. So overall, it's pretty much a wash on the wetlands. So I'm going to turn it back to Tim. Or Tim, since it's really not working, if you want me to just advance your slides, I will be quiet and you can just let me know when to advance them.
Okay, that'd be great. Appreciate it. Thanks, Wayne. Maybe I shall clarify a little bit for you some of the definitions for the ecosystem services on a broad context. And I'll just read you a couple of definitions for this. The regulating ecosystem services, those are services that maintain this is a quote, they maintain a world in which it is possible for people to live, providing critical benefits and buffer against environmental catastrophe. So those are the regulating ecosystem services, and that's why we have flood and disease control as a subcategory underneath this regulatory ecosystem services. Now, we had to figure out a way to measure impacts of the project, and we're calling those metrics. So the key metrics that we were used as the surrogate measures, because some things you can't measure directly, you have to take something on the landscape and say this will represent the impact on the regulating and service. So that's what we've done. And in this case, the number of structures or buildings and bridges located within the 100-year flood zone downstream of the dam was our surrogate measure for an impact. A secondary metric that we used was the change in floodplain area downstream. So this little table here that presented shows you what we had when we started out the project, the number of structures. I'll just read the slide for you. It says number of structures in the 100-year flood zone. You can see the existing conditions was 126, and after we still have 126 in the 100-year. As far as acres of land in the 100-year flood zone, initially we had 128, and when we finish the project, we'll only have 126 acres of land in the 100-year flood zone. So next slide, Wade. Moving on then to the supporting ecosystem service. I'll just read you the definition that's provided for the supporting ecosystem service. Refers to underlying processes maintaining conditions for life on Earth, which includes nutrient cycling and soil formation and some other facets of supporting ecosystem services. So we picked nutrient cycling. So the key metric we use to represent nutrient cycling is vegetation, because plants use nutrients, they decompose and provide nutrients, so it's a cycle of nutrient transfer in the environment. The permanent addition, disturbance, or removal of vegetation will have a noted impact on nutrient cycling. So therefore, we looked at all three alternatives. I'm going to focus here on number 2, alternative 2, because that was the preferred alternative, as we've stated it earlier. And you can see that the existing condition had 20.505 acres of vegetation initially. And when we finish the project, we'll have 19 acres of vegetation. And that's due to some of the concrete that we're going to put in place. We're going to lose some vegetation. So we had a net loss of about 1 acre, or 208 feet by 208 feet of vegetation. Next slide, please. The next facet of supporting ecosystem services is soil formation. The key surrogate measure used to represent impacts on soil formation is the change in acreage and impervious surfaces in the limit of disturbance, which is indicated by the red hash marks on your screen graphic. The addition of impervious surfaces will inhibit natural soil formation. In other words, microbes don't exist very well in concrete. So, and other reinforced materials. So we're going to have an impact where we have impermeable surfaces. So let's take a look at the impacts for alternative 2. We had 0 existing condition acres impacted because we don't have any addition of concrete. And then with the project, we're going to have 1.05 acres of impervious surface that we didn't have originally. So we have an increase of impervious surfaces of 1.05 acres. So we're going to have that much less soil forming acres. Next slide, please. The next ecosystem service category is the cultural ecosystem service. And it's defined as those services that make a place in which people want to live. So in that light, we looked at the aesthetic viewshed, or what people see when they come to the park area and the dam. And we use that as our metric to measure impacts. The key metric used was viewshed, and the impacts were acres of green landscape within the limit of disturbance that may be converted to impervious surface. A second metric used was the number of residences which have a direct line of sight or view of the limit of disturbance and pose changes to the project area. So I mentioned that earlier, that we have a couple residents that have a really nice view of the park area. And so what they see is going to change with project. So just looking at alternative 2, which is the preferred alternative, we see that the green landscape under existing conditions is about 20 acres. And with project in place, alternative 2, we're going to end up with about 19 acres of green landscape. So we lose about 1 acre of green landscape due to the implementation of the project and the use of concrete in the project dam. I think those are all my slides, Wade. Oh, got one more, sorry. Again, this is a recreational use category underneath the cultural resource ecosystem service. And the metric used to represent recreational use was the estimated acreage of land used for recreation within the limit of disturbance, which will change as a result of the alternative. So we know that there's some hiking that takes place in the park area. They use the trails and so forth. And so we were concerned with changes in that recreation area. So looking at alternative 2, we looked at linear feet of trails. So we have initially 605 feet, linear feet of trails that may within the limit of disturbance. And then after we put in the project in place, we'll have 960 linear feet of trails. And part of that is due that we may do some improvements in some of the trails, and so we end up with a plus 355 linear feet of trail as a result of the project. Additionally, the dam will be returned to its original constructed purpose, serving as a dry dam as a result of the small pond impoundment upstream of the dam. It will revert back to a stream channel and will revert back to stream channel. This will result in the loss of approximately 2,500 of recreational open water from the implementation of all the alternatives being considered. So because it is a dry dam, we won't have ponded water in back of the embankment any longer. I think that was my last slide. So next.
Okay, thank you, Tim. And some of the additional environmental effects, vegetation, we're talking about trees will be cleared as necessary to facilitate ingress and egress and staging of materials into the construction. And we're estimating that about 3 to 4 acres of vegetation will be cleared in the staging area. Trees will only be cleared as necessary to facilitate construction. So some of the vegetation may just be grasses or shrubs and things like that. We'll try to protect as many trees as we can in that staging area. The construction on the auxiliary spillway and the exit channel will permanently impact established vegetation less than 2.5 acres of grass. So we may have replacement of a lot of that, but you heard Tim talk about a lot of the changes that might happen there. Best management practices will be implemented to prevent the spread of the Phragmites during construction, and there would be some minor disturbance to the repairing areas downstream. Wildlife, we think that the impacts on the northern long-eared bat can be avoided with time of year restrictions and no impacts to state listed animal species, and that we would have a pedestrian pathway at the dam included as a design component. So you could include pathways there for for folks to recreate. Shifting gears to land rights and easement issues, here's a map that shows the original construction and what's happened. This is the dam down here, and the cross-etched area is the original easement land that was acquired by the city to build this dam. The red line, as you see it here, is the elevation of the crest of the auxiliary spillway. This is where the permanent or during flood stage, when it gets up to a 100-year storm or so, it would flow over that area. And then stepping up to the existing top of dam is the blue line around here, and the new 2-foot dam raise that we're talking about, the proposed 2-foot dam raise would increase up to the yellow line. So the orange or brownish looking land here is owned currently by the city. So the impacts of any additional land rights and so forth could extend out on some of these areas. This is Interstate 90 up here, and then the railroad is running along this side. So you can see it's sort of somewhat, I would say, busting at the seams a little bit and expanding here. So some of these easement areas would need to be considered. So I've got a slide here that shows some of those easement issues. For the original construction in 1965, the city purchased the land as shown on that previous slide. And for rehab, when we're looking at 50 to 100 years down the way, the current NRCS policy requires the minimum land rights upstream of the dam to be to the crest of the auxiliary spillway elevation or the 100-year 24-hour storm elevation, whichever is higher. And it was determined that the auxiliary spillway crest elevation was higher. So that's the minimum land rights that must be acquired, and that elevation is not changing. The auxiliary spillway crest is not changing. So our economist, James Featherson, will do a flood pool risk analysis, and we're in the process of getting information from the city on easement costs and recording and things like that. But a flood pool risk analysis will be performed for all those areas below the new proposed top of dam elevation. And the city will decide whether to require the additional flood easements above the auxiliary spillway crest or accept the risk of flooding to the top of dam elevation. Again, you got to look at those, you're talking at those very infrequent storms that would get all the way up to those elevations. So that's something that has not been completed at this point, but it's a work in progress. Okay, agency consultations on any of these dam rehab projects or any planning projects when you're involved in federal funds. We have to consult with other agencies that are associated with permitting and environmental regulations and controls. So we'll be sending out consultation letters to the following agencies: Corps of Engineers, Fish and Wildlife, Natural Heritage, the State Historic Preservation Office, the Department of Environmental Protection, Massachusetts Dam Safety, and tribal organizations. So those folks will be consulted with summaries of impacts and maps, and we'll be working with them going forward.
You want to watch it, go to channel 15.
No, I don't want to watch it. I'm going to.
All right. On the overall planning schedule, what's coming up in the next several months, the initial plan for internal review is that'll be sort of between the sponsors and NRCS. Once all the documentation is written down and put into a book format, that's due in early December. There will be a preliminary plan sent out for the technical review by the NRCS. There's a National Water Management Center in Little Rock, Arkansas that does the technical reviews of all these planning documents. That would be in late February. Then a draft plan would be sent out once it's more or less finalized or in a draft stage for public and interagency review in May. And then a second review would go to the NRCS National Office in July, and then the final plan would be in August of next year. And then following the completion of the planning process, if the project's going to proceed to design and construction, then the NRCS and the city would have to request authorization of the plan by the chief and then request funding for design and construction. So right now the funding is not in hand for the design and the construction phase. It's just a planning phase. So here are the points of contact for the project for NRCS and for the city. Right now we're saying if you have concerns or questions related to this project, you should contact Jim Lyons with NRCS or Mark Crissati. And this meeting is being recorded, and the PowerPoint will be posted to the city's website. So you will have access to that information for anything that you might need there.
Al, Wade,
Yes.
I think they should be able to contact Al as well.
Oh, absolutely.
Correct. Yes,
Absolutely.
yeah, as chair of the flood control, I am also available as contact.
Yes. Good point. Thank you. And that is the last slide that I have. So I will stop sharing and turn it over, I guess, to Al, if you want to coordinate the Q&A and however you
Sure.
want to proceed.
Sure. Let's see. I believe we had one question on the Q&A down there. Looks like it might have been answered.
That was answered by Sal.
Okay. So just to read it out to everyone, will the forested staging area be restored with native species after the project is finished? Its loss was not included, but is significant. And Sal, if you want to respond to that, or I can read it, whichever you prefer.
Yep, yeah, I can read it. I just responded, yes, all cleared or disturbed areas during construction will be restored at the end of construction with native seed mixes. If necessary, the city may work with individual property owners on additional restoration requests related to the project as needed.
Thank you, Sal.
No problem.
I did find an email or a Facebook question that popped up because I was monitoring Facebook because I posted this all over Facebook, and it was also shared, I believe, by one or two city councilors. I'm trying to stay, sorry, I'm getting other things on top of
Al?
what I had. Yes. Yes.
This is Tim. I just wanted to expound a little bit on Sal's statement.
Absolutely. Go ahead.
Sometimes native species are hard to come by and they're really expensive. And also, we're required by principles, requirements, and guidelines to be cognizant of the fact there may be some climate changes coming. And so they're really concerned about building resilience into any revegetative work which takes place on our disturbed sites. So in that regard, we may choose some adaptive species in lieu of all native species, just for those two reasons.
Thank you, Tim. I do know one of our co-sponsors, the Hamden, Hampshire, Franklin County Conservation Service, if I'm correct, because I believe it's the three counties together. They do have I don't believe anyone from that agency is here, at least not on the forum as far as I can see. But they do have native species that they sell. I don't know if that's something that they could provide at some point and coordinate with them. I know they have some limitations as far as their funds go, but just to put it out there. Let's see. I do have another question. I'm trying to put it into a way to make sense of it. But there was a slide early on that was pointing out, and I don't know if you can pull up the slide from the beginning, where it was referring to the expected costs of flooding with the dam and without the dam. It was a $200,000 number. Are you able to pull that back up, Wade? It's somewhere in that area. It had two numbers. It had one of, there we go. That's it. So just for clarification, the without the dam and with the dam in place is what the cost would be from flooding resulting from if we had no dam at all, or if we have the dam in place with the upgrades and rehabilitation undertaken. Is that correct?
Yes, that's correct. There are still drainage areas that are uncontrolled that get into the downstream floodplain. It's not just the water that's coming through this particular dam that affects the downstream properties. So, and these are all flood events. It's not just the 100-year flood event. It could be a 500 or 1,000-year event or whatever. So you annualize those damages over all flood events. So there are continuing damages even with the dam in place for all those reasons. It's a lot of uncontrolled drainage as well as other storms that may exceed the design and the storage capacity of this structure. Okay.
Just to follow up on that, Wade. So what was the average time span that was used to get these averages? These are, I'm assuming these are yearly averages.
I might defer to James if he is still on. James Featherson is the economist. I saw he was on earlier. James, are you still there? Can you answer
yes,
that
I
question?
am. Yes. We amortize the damages over roughly a 100-year period to get an annual value. And so that's why it's called an average annual value. But as Wade said, it does include like the 500-year event storm, the 100-year event storm, as well as other frequency storms less than 100-year.
Okay, thank you. So just so people are aware, these are not numbers with say there was a breach, what the impacts would be. This is just if we didn't have a dam or with the dam being in place. This doesn't include the catastrophic failure of the dam, what those totals would be for damages. Just so people are clear. I think there was some confusion with that.
That is correct. You are correct, Al.
Okay,
yes.
Thank you. I have two questions. I have one person, city councilor raised her hand and she's allowed to speak, but I have a question that came in, I think just before that. It says, if the bats roost in trees and snags during the summer months, will they be posting bat houses during the project period?
Yeah, I'll take a stab at that, Al. So the U.S. Fish and Wildlife Service, who we will be consulting with, stipulates time of year restrictions to protect northern long-eared bats. So that time of year restriction restricts the taking of trees greater than 3 inches diameter at breast height from April 1st through September 30th. So during that time frame, there is no clearing of trees on site, so that to eliminate the risk of taking trees down while bats are roosting in them. So we will adhere to those during construction, and then once those are down, construction can commence, and then that will be taken care of from the Fish and Wildlife standpoint, the potential risk to bats during the project. We're not proposing to put any bat houses up. We're just doing the avoidance measure as recommended by the U.S. Fish and Wildlife Service.
All right, thank you, Sal. All right, City Councilor Mello, Kristen Mello.
Thank you so much. Can you hear me now?
Yes, ma'am.
I was just wondering, based on those previous calculations for damages, when we are talking about a very large storm with a rehabilitated dam, what kind of protection are we going to see in advance while the construction is going on? Is there going to be a period of time where the neighborhoods downstream are going to be with less protection than we might otherwise be? Is there any kind of period where we will be less protected? And thank you.
Thank you, Kristen.
This is,
Carl,
I
Carl, could you take that?
yeah, I'll take a stab at that, yes.
Thank you, Carl.
So the proposed sequence of construction does not lower the flood risk, does not increase the flood risk downstream. Construction measures would be in place to retain the 100-year event. Beyond the 100-year, there probably would be some risk, but up to the 100-year event, that would be no change.
All right, thank you, Carl. Councilor Mello, does that answer your question?
Yes, so you're just saying that there won't be any period of time where, we need to be more careful, or we need to have residents take any of their own measure. There's no period of time where we're going to have less protection than we have now during construction while things are happening?
Well, there is a risk, the risk and uncertainty. Putting in the labyrinth weir, we are lowering that auxiliary spillway several feet and doing the construction there. The sequence of construction and the measures that the contractor would be required, we try to minimize that, but there is that risk in that period that could be unstable. Darren, I don't know if you want to get into some of that and how that could be handled at the next level. Or Jim?
Darren, your audio, there you go. Your audio's back.
Okay now? Okay, good. So one thing, to keep in mind is, we would certainly be monitoring construction, as would the contractors that are doing the work, and they would be monitoring the weather as well. And to get an event that's going to be a 100-year storm event, we're going to have some time seeing that coming. I can't guarantee that it will, we'll have a week, but we'll have some time. So that would certainly be something we would take very seriously and be monitoring as construction is progressing. So as we're going through the schedule and proceeding, that would, if we see a tropical storm or hurricanes are coming up the coast, or we would certainly accommodate, shift our focus to make sure anything that we had happening, we'd take every precaution we could to install temporary measures, or delay excavation of something or installation of something, and react accordingly. So that's one thing to consider, is something of that size historically doesn't just pop up and show up on us. That's something that's is able to be tracked, certainly. So that's one way to consider that. I don't know, Jim, I know you've been on some construction sites dealing with some of that. Is there anything you want to add?
You addressed that pretty well, Darren. The only other thing I'd want to add is we will be working or going through the Office of Dam Safety for Massachusetts, which will be permitting the project. And they have specific guidance and regulations to make sure that we can convey water through the auxiliary spillway if we do have a large storm event. So that will be taken into consideration. However, there is still a little bit of risk out there because we will be working on the structure, but that's something that we would be tracking, the contractor would be tracking, and the Office of Dam Safety would be tracking to minimize that risk.
I can give you maybe an example. I remember when we talk about hurricane or tropical storm Irene, I was working in New York at the time, and if you remember, tropical storm Lee came up from the Gulf, a week, 10 days later, and hit two spots and you know, a couple spots in New York were hit twice, really. And we, after the damage from Irene on one of the dams, we scrambled and installed a temporary earthen impoundment. You know, we basically built a dike across the auxiliary spillway that had seen flows and had eroded downstream. It did not fail, but it was downstream, there was damage. And we thought, wow, if we get another storm that's going to activate the spillway again, it may continue to cut back and give us problems. So they were able to mobilize and put a dike across that area to, you know, to protect against it. So that's one example where things can move quickly if, you know, it's not unprecedented to react to something like that.
Yeah, this is Carl. I just want to compliment Jim. We had slides of the Nichols Dam in Westboro, and Jim was the project engineer, and we had the Nichols Dam fairly well torn apart when Irene came up and hit. And there were several days that Jim didn't get much sleep, but measures were taken with the contractor to avoid any downstream problems. And certainly the service acted quickly on that. And it, you know, as Darren and Jim have said, the similar actions would occur here.
Thank you.
Thank you so much. I would just ask that we establish whatever communications would need to be in place for Al and emergency management and Chief Egloff and the businesses on North Elm Street and the downstream residents, just so that everyone can get information as immediately as possible right when they need it. We don't have to build that plane later on. Thank you so much, gentlemen.
Thank you, Counselor. Yeah, I think I'll speak to that. I imagine, and Darren and Jim could probably speak to it a little bit with their experience, but I think we would have a general contact list of emergency contacts in a storm event. So if there is an emergency, all the parties that are relevant would be in immediate contact. And NRCS and the contractors have been in pretty good regular contact anyway. So hopefully that'll not be an issue. I will do my best to make sure that's not an issue if that alleviates that concern.
Thanks so much.
You're welcome. I don't see any other questions. Is there any other
Commissioners Committee?
Absolutely. John Leary, Jack Leary, you have the floor, by all means.
Okay, you've covered pretty well the dam itself. My questions would be related to the staging area. I'll give them all at once to be simple, I think. The first one is, does the city of Westfield own presently the staging area? The second would be, is the staging area the same when the number or amount of concrete varies from one proposal to the other? And the last part of that question would be, if we have to remove trees and vegetation, are we required to replace some type of vegetation and trees that are appropriate for that area? That's it.
Thank you, Jack.
Well, I will start. This is Wade, and I can't speak to the existing ownership of the property, but Mark, you might know that, but the staging area right now, we're considering all of that limit of disturbance to be the same for all four alternatives. And we threw that net fairly large there because we'd rather cover more in planning than we need, rather than have to come back and try to do a modification to the existing plan or any kind of revisions, or go back into the planning phase while we're in design or while we're in construction and we find we've left out an area. So we've thrown that net fairly large there, and we think we've covered everything that would be necessary, for all four alternatives. So the staging area and the limits of disturbance would be the same for all four areas. And regarding mitigation or coming back to replant trees, we would be working with the permitting agencies when we have final design and we would know what those impacts would be. Then we'd work with the permitting agencies to see if any mitigation or replanting of those, any trees that were taken would be required.
Okay, thank you.
Mark can speak to it as well, but my understanding is that the parcel that is being looked at, the vast majority of it, I think a small piece of it's owned by the city, but the vast majority is not at this time. Am I correct on that, Mark? I know a good portion of it's not. Your mic is off.
You're right, Al. The majority of that property is not municipally owned. It is something, though, that the city has looked at as far as acquiring for some time. Again, we'll work through that as we work through the process here.
Thank you. Jack, does that answer your question satisfactorily?
Yes, thank you.
Thank you, Jack. Thank you, Mark. Thank you, Wade. Let's see. Mark Goodness, do you have any questions?
None, sir. Thank you.
Thank you, Mark. And Barry, do you have any questions?
No.
Okay.
No, that's it's been explained pretty well.
Yes, thank you. I see City Councilor Bridget Matthews. Councilor, do you have any questions you would like to ask?
I'm all set. Thanks so much.
Thank you very much. I see a comment in the chat from Councilor Mello. Thank you. I thank you so very much, everyone, for an informative presentation and for promising to keep the downstream residents living in a recognized environmental justice community advised of any potential hazards to them during dam rehabilitation. Your work is much appreciated. Thank you, Councilor Mello. And with that, I have no questions. So if there's any closing comments anyone would like to make, by all means, you have the floor.
Well, this is Tim. I just say we appreciate working with you guys, and it's a team effort to pull together a project like that, and everybody needs to do their part. And Mark's been really good, and you've been really good, and all the folks there in the city have been helpful to us, and we appreciate it. And I can't say enough about, Jim Lyons and his help. He's kind of the go-between, and he's really helped in a lot of situations. So, and Darren, he's kind of off there in the shadows, but we know he's there. So thanks, Darren.
Hello.
So absolutely, Tim. Yes, and thank you to the team.
Yeah.
So yes, thank you to the team we have assembled here. It takes a lot, like you said, and I really appreciate it. And it's easy for me to rely and to lean on Jim Lyons. He does a good job and really helps coordinate all of this effort. And so certainly Al and Mark from the city, I appreciate everything. You're very quick and forthcoming with getting information to us and helps keep the process moving. Because when it's something this large and there's a lot of moving parts at times, and we really, it's helpful to keep things moving along. So I'm looking forward to as we continue through the process here. So thank you very much to everyone. It's a very good presentation today.
Yes, it was. Thank you, Darren. Would anyone else like to make any closing comments? Jim?
Yep, I would just like to thank the city and the Flood Commission, Al and Mark Cruzati. You guys are a pleasure to work with, as well as Atera and Schnabel, in working our way forward for moving this dam to rehabilitation. I greatly appreciate all the hard work that you guys are doing, and thank you very much.
Thank you, Jim. And I concur with all the comments. I mean, it's been a very incredible effort so far on both of the dams. Mark, would you like to make any closing comments?
Yeah, if I may, Al, thank you very much. I just want to look. I do appreciate the presentation. I think you guys did a very nice job. A good layout of alternatives, whether it's a no build or build and so forth. So I certainly appreciated where you're coming from on that. I guess wanted to paint the picture of potential here beyond flood protection, that the city is looking at potentially using both this dam and the Armbrook Dam for a multi-use trail along the top to connect just locally the high school to the middle school, but statewide and regionally, this would be a continuation, if you would, of the Massachusetts Central bikeway connecting, Boston to New York, and it all fits in, and it's a bigger picture, but and there's a lot of obviously details, but this work does factor into a larger picture of bigger enhancements that the city would come to appreciate and enjoy in time. So there's more to this story than what was just been presented, though what was presented was a very good job. Thank you.
Thank you, Mark. So just to add to what Mark was saying, I mean, there's definitely benefits for recreation that will come out of this project. It may be some time before we see them up front, but it ties in with a lot of the ongoing projects that we have in the city for recreation, and it improves the communities to some degree. But also the flood control, which is its primary goal. The flood control aspect, that can't be discounted and it shouldn't be ignored. I mean, it's a public safety matter. It affects people's lives, businesses, infrastructure costs. If we have routine flooding, it damages our existing roadways, bridges, infrastructure. We have enough problems in Westfield as it is. And, a lot of the infrastructure we have regarding flood control in the city wasn't maintained for a long time properly. And, we're making great strides in the last 10 years to get all of our flood control infrastructure to where it needs to be. And again, it's a public safety issue. It's protecting people's homes, their businesses, people's lives, schools, roads, the railroads, jobs. I mean, the flood insurance costs, it reduces those costs for residents that are in the flood zones, and much of Westfield is in a flood zone. So, there's a lot of things to factor into this. It's not just something that's out of sight, out of mind. And unfortunately, we don't see these things or acknowledge these things until we need them. And when we need them, if they don't work, that's a major problem. And there's plenty of examples you can look at just in the last handful of years of examples where flood infrastructure failed or wasn't up to the task that it was designed to do, or it was aging, such as ours, and had some issues where those items didn't do what they needed to do, and a lot of people were affected very negatively. So it's a lot to consider. But with that, does anyone have any last comments they would like to make before I call for adjournment? Seeing none, I will again.
I'll make a motion to adjourn.
Before you do that, Jack, I'd like to thank everybody that was here this evening for the presentation. It was outstanding. I think this was by far the best presentation, even though it's on Zoom. It's the best presentation we've had yet. You guys did an outstanding job with all the information, and I appreciate all the work and time you've put into this and all the communication. Thank you very much, everyone. And Jack has a motion on the floor. Do I have a second?
I'll second it, Barry.
Seconded by Barry Plumley. All in favor?
Do we have to do roll call on these Zoom things, or?
We do. All in favor? Jack Leary?
Yay, yes.
Mark Goodness? Mark Goodness is muted. Mark Goodness, can we unmute him?
*6, Mark.
Press *6 on your phone, Mark Goodness. Barry Plumley.
Yes.
Okay, Al Jaguar, yes. Mark, unfortunately, he hasn't gotten it opened up. So with the three, we do have our...
hung up.
No, he's still there. I can see him. With the three, we have our quorum, and I will make do with that. And unfortunately, Mark, has a technical issue at the moment. So we'll leave that alone. All due respect to Mark, but we have a quorum. The vote to adjourn has been made. Thank you, everyone. Thank you to everyone that's watching this on YouTube, on Facebook, on the city channel, or will watch this in the future. I appreciate your time. Please reach out to us, reach out to me. Any questions, any concerns, any comments, I'm here, I'm available. I will make myself available if I have to in person to talk to you or address the concerns. Thank you very much and have a good evening. God bless. Oh, and I forgot, Peter Cowles, thank you very, very much for everything you've been doing for us. I'm so sorry,
worries.
Peter.
No worries.
I failed to acknowledge you and I apologize greatly. You've definitely been